All right, let's look at the exponential growth and decay problems. Right, the first one, the population of a certain village has this as the rate. So you know what, you use the rate. So you kind of take what we want, what we need. Okay, so here, just kind of wrote out the formula that they gave there, where this is the last amount, the total amount. The PO is the initial amount when time is 0, and then you have that natural exponent, and then K is the rate, and T is the time. So we have the rate, and then we have the current amount, which is the initial amount it started with. So you can kind of write the formula out, and then write out everything you need in the formula. So PO, write it out, your rate, change it to decimal, and then your time they gave you for 5 years we are finding. Then we are looking for P of 5. So when the year is 5, what will be the total? That's what we are looking for. So plug things all into the formula. Okay, so this is the formula. So we are looking for P of 5. T is 5 now. Equals our PO is 25,000 times the exponent, and our rate is that in decimal now. I will put it in parentheses the way I'm going to put it in your graphing calculator, and then times the time, which is 5 years. If you like, of course, you can multiply that before you put it into your calculator, but the graphing calculator will also do that for you. Okay, so we just get our calculator, plug things in. So that's there. So go to, just plug it the way it is. Gonna do 2500, that's 25,000, times your multiplication sign. And then we put the exponent, the natural exponent is right here. You see the second, for mine is second E, you see the second E right here. Okay, so that's the natural log is on top of it. So you press the second natural log, that gives you the E. Again, I'll put parentheses because I have two of them, two things there. So those two, that's why I put parentheses so that I can multiply them. So 0.039, so 0.039, and then times of that parentheses times 5. Then I close my parentheses. Okay, hit enter. It gives us that. So that's 3. Okay. So P5 is equal to 30382.77. All right, but they want us to round to the nearest 100 of people, nearest 100. So the 100 place, we identify the number in the 100 place. This is in ones place, that's decimal, ones, tens, hundreds. So 3 is in the hundreds place. Our number has to end here. But then we need to look at the right, see if it is 5 or more. If it is 5 or more, we borrow 1 and then we round up. So we add that 1 to 5. So that's going to be 304 now. And then we put 0 on every other thing. Okay, put 0 there. So we don't need the decimal. That's our answer. So P of 5. So in 5 years, there will be 30,400. All right, the B part is asking how long it will take for the population to reach 40,000. So we're looking for the time, how long. So we're looking for T. So again, we write out all with the information we have. So they gave us the P of T, which is 40,000. K, which is the rate, is the same. And then PO is the same. So we plug things into the formula. So P of T we have, it is 40,000. Okay. And then equals our PO. PO is 25,000. And then times E to the power KT, which is the rate, which is 0.039 times T. We don't know T, so we put the variable there, times T. This is 0, okay? All right, so then we try to solve the equation for T. T is the exponent. So first of all, this is multiplication. We go ahead and divide both sides by 25,000 to get rid of the 25,000. Plug that into our calculator. So 40,000 divided by, you can also cross this out, cross that out. I already typed this, 40,000 divided by 25,000. That gives us 1.6. So 1.6 is equal to, so this crosses out that, so we are left with E power 0.039 T. All right, at this time we need to bring T down, so the only thing that can bring it down is taking the logarithm, log of both sides. Since we have the natural exponent, so we want to take the natural log. So the natural log of 1.6 is equal to the natural log of E, 0.39 T. So T comes down. I mean, this whole thing comes down. So 0.39, oh, I'm sorry, I'm missing 0 there, 0.39, okay, T was times natural log of E, and natural log of E becomes 1, so this is actually 0.039 T equals natural log of 1.6. So we take the natural log, plug it into the calculator, divide by 0.039. That gives us T. So if we divide both sides by 0.039, go to the calculator. So my natural log of 1.6 divided by 0.039. Okay, hit enter. That gives me 12. That's 12.051337, keeps going. Okay. But then they want us to round to the nearest tenth. Okay, 10th of year. So 10th is 1 decimal place. So we go back here. The number in the 10th place is 0. So we have to look to the next right. It's up to 1, so we carry 1, is up to 5. So we carry 1 from there and round off 0.1, 1 plus 0. Okay, so it's going to be that number of years. And let's look at one with exponential decay, and then we find the rate. Okay, we have found the final amount or final population, and then we have found the time. So let's look at how to find the rate and then practice exponential decay. Okay, so we are so that this scientist is working with laboratory sample, and here they give us the half-life. The half-life, okay, is 40 years, and the original sample, which is your PO, so your PO is 100. The time for the half-life is 40. Okay, so we don't really need this. This is not the rate. This is just the rate it decreased by. Okay, by how much amount it decreased. So we are just finding the rate. We are looking for the rate. Okay, so for P of 40, at 40, when time is 40, so the PO gets down to half. So 1/2 of PO, 1/2 of the initial amount, which is 1/2 of 100, which is 50. So any of these expressions, any of these 4 expressions can go to substitute for your PT. So whichever one you choose. If you choose the variable part, it's going to cross out anyway, but you use the variable part for this PO, use half of PO, they're going to cross out. But if you want to put the number, any of these will work. So you can put the number there. So 1/2 of PO when time is T, when time is 40, is 50. Equals, okay, the PO 100, then E to the power. Okay, we are looking for T is 40, so it's negative 40. Okay. Again, if we had wanted to do P of 40 equals PO E KT, if we had replaced this with 1/2 PO, and then we keep this as PO times E times negative 40T, see what's going to happen. We can divide both sides by PO, that will cross out right away. That way we don't have to work with numbers. We'll still have 1/2 equals E to the power negative 40T, okay? But anyway, even if you plug in number, you're going to get the same thing. So use your calculator, divide both sides by 100. So if we divide 50 divided by 100, give us 0.5, which is 1/2. Okay, so if we divide both sides by 100, so that will make this 0.5 equals E to negative 40K. So either way, you get the same expression. 0.5 is 1/2, whether you work with fraction. So, all right. So now we can take the natural log of both sides. In 0.5 equals natural log of E negative 40K. So this brings down the exponent. So we have natural log of 0.5 is equal to negative 40K. Okay, because this becomes 1 when you bring that down. Okay, so now we can divide both sides by negative 40. Get our K. So the natural log of 0.5 divided by negative 40 is 0.017328 and keep going equals K. And they want us to round to nearest 10,000. 10,000. Okay, so find the 10,000 place. 10,000 place. So this is 10th, 100th, 1,000th, 10,000. So it has to end here. So we look to the right, 2 is not up to 5, so we ignore it. So it's going to be 0.0173. Okay? That's the K, that's the rate. And if you want it to in percent, just multiply that by 100, and then we're going to get 1.73%, just in case. Okay? Same thing.